Hello students, today the agenda is to check your homework, we're going to be learning about how to solve simple quadratic equations, and your homework will be 10.7. Today students will be able to solve simple quadratic equations by elimination. Before we even start with the lesson, I'm going to teach you the perfect squares. I'm going to do a list of all the perfect squares, and it just means numbers that can be, that when you take the square root, you get a whole number. And so it would be 1. Why? Because 1 times 1 is 1. It would be 4 because 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 36. 49. 64. And again, it's just 8 times 8, 7 times 7, 6 times 6. The next one is 9 times 9 is 81. 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196, and 15 times 15 is 225. Again, these are the first 15 perfect squares, and we're going to be needing them for the lesson, or just in general. When we're factoring, it makes our lives easier to see which numbers are perfect squares. Another thing that you need to know for today's lesson is square roots. So when I'm talking about the square root of 36, most people will give me the answer 6, which is correct. But we can also say that the right answer could also be -6. Why? Because we're looking for a number that multiplied times itself is this number inside of the square root, which is 36. And we can say that 6 times 6 is 36, but also -6 times -6 is also 36. Okay, so both of these are correct answers for the square root of 36. Again, whenever we're taking the square root of a number, we can say that we have the positive and the negative of the square root of that number. Okay. So another example is the square root of 25. The answer will be 5 or -5. Okay. What else do we need to know for this lesson? We need to know that the inverse operations cancel each other. For example, if you're adding 5 and you subtract 5, you get 0, so they cancel each other. And then if you multiply by 2 and then divide by 2 that same answer, you will end up with that same answer. So whenever you multiply and divide by the same number, the answer will be 1. Okay, so they cancel each other in equations. And now the new one that you will learn is that anything to the second power cancels with the square root of that anything. So basically this square root cancels the square. Okay, so the square is the inverse operation of square root. So these cancel each other. Addition and subtraction, multiplication and division cancel each other, and the square and the square root cancel each other. Okay, now let's start solving some simple quadratic equations. And so number 1, if I have x squared is equals to 36, what is the value of x? As mentioned before, I want to leave x by itself, so the inverse of square will be square root, but if I do it on one side, I do it to the other. And so my x is equals to, we say 6 or -6, okay? So both of these are valuable answers. Another way to express it is x is equals to positive or -6. So in here, it includes both answers, okay? Both are correct. Whoops. Okay, another example. If I'm squaring x, that's equals to 100. So to find the value of x is take the square root of both sides. The square root cancels the square. X is equals to positive or negative. What's the square root of 100? 10. So it can be positive or negative 10. This includes my two answers already. Okay, so make sure that you don't forget to put the minus, because some people will just say 10. You're giving me half of the answer. What about x squared is equals to 5? Same thing, we take the square root of both sides, and this cancels. So x is equals to, now in here, eventually we're going to be using our calculators to get the exact answer. But for now, we're just going to leave it as simplified. Okay, so later on, we're going to be using our calculators, so we press the square root and then the 5, and we get that the answer is 2.236067797, etc., etc., etc. This is an irrational number. It means that the decimals go on and on and on without repeating. For now, we're just going to leave it as the square root of 5. But just remember that it's always positive, negative, and then square root of 5. This is how you would leave it for now. Later on, when we're graphing quadratic equations, then we will need to get the approximation of those, of square root of 5. Okay, the next one is a very interesting case. We have x squared is equals to -4. We take the square root of both sides, but what number multiplied times itself is -4? We say plus, minus, and some people will say, oh, -2. Well, -2 times -2 is +4, so that doesn't work. Other people will say 2. Well, 2 times 2 is +4, so that doesn't work either. And some people will come with something as interesting as +2 times -2, which will be -4, but then it's not following the rules. We're looking for a number that multiplied times itself is equals that number. And since nothing works, mathematicians came up with a system that is used in, I know for sure, in electricity. So whenever they have a negative inside of the square root, it simplifies as an imaginary number, which they write with this little symbol. It's a letter I, okay? It's an imaginary number. And we'll give more detail in the future about it, but anytime you see a negative inside of the square root, take it out as an imaginary number. And the square root of 4, that's a 2. Some people will write it in here, but usually coefficients are written before the variables. Okay, so my answer is going to be equals to positive or negative 2 from the 4, and then the negative simplifies as an imaginary number. Okay. Okay, so now let's look at some examples that have more than one step. They're still simple. So if I have x squared minus 9 equals 0, I cannot cancel this square, so I'm going to cancel the minus 9 first. So if I'm subtracting 9, I can add 9 to cancel that, but if I do it on one side of the equation, I have to do it on the other. And so x squared is equals to 0 plus 9 is 9. Then I can get rid of the square root, the square, by taking the square root on both sides. This cancel. And so x is equals to, remember, every time we have the square root is plus or minus. The square root of 9 is 3, so plus or minus 3. Two different answers, okay? You have, the answer is positive 3, the answer is negative 3. And this is going to be helpful because later on we're going to be identifying these as this being negative 3 and this being the positive 3. Two different answers, okay? Well, that was exercise number 5, or example number 5. Okay, one more example like that. So first I'm going to add 121 to both sides. And so x squared is equals to 121. We know that that's one of those perfect squares. And we take the square root of x squared, or both sides. This cancel, and so x is equals to plus or minus 11. Okay, both answers are given in here. I'm kind of going a little bit fast because it's a little bit more repetition of what we are doing with the first ones. So what if I have x squared plus 25 equals 0? Well, in here I'm going to be subtracting because those are the inverse operations. And so x squared is equals to negative 25. To solve for x, to leave it by itself, I'm going to take the square root of both sides. This cancels, and so x is equals to plus or minus. This becomes an imaginary number, and the square root of 25 is 5. And remember that we always put the number first because it's a coefficient with its variable. Okay, so that will be the answer. Remember, anytime you have a negative inside of the square root, it simplifies as the imaginary number. Okay, let's move to some a little bit more complex. Nothing out of this world. In here, we cannot cancel the 9 first because it's protected by those parentheses. The whole thing is raised to the second power. So that's what we need to cancel first. We're going to take the square root of both sides. And so the square root cancels with the square. And so we end up with x plus 9 is equals to, we would say plus or minus 0, but we never have a negative 0. So if you want to write it, that's fine, but in reality, it would just be 0. In fact, we don't even have a positive 0. It's just neutral. We subtract 9 from both sides, and so x is equals to negative 9. Okay, he doesn't get affected by the 0. I'm going to do a couple more exercises like this, so you don't need to repeat it unless you want to, but okay, so if you have x minus 3 all raised to the second power, we take the square root of both sides. We end up with x minus 3 is equals to, remember, always the positive and the negative of the square root of 4 is 2. And then we're going to add 3 to both sides. And this is where it gets a little bit tricky. So this 2, we can say that it's positive at one time and then it's negative at another time. So some people like to separate it and say, okay, if I have positive 2 and then I'm adding 3, or I have negative 2 and I'm adding 3. Remember that we're adding to the 3 to either the positive or the negative 2. And so the answers for x are going to be 2 plus 3, 5. Negative 2 plus 3, it's 1. So these will be the two answers for x. So x can be equals to 5 or 1. Again, I put, because the 2 in here, when we take the square root, is plus or minus 2. So we have the plus 2 with the 3 is 5. And the negative 2 plus 3 is 1. Okay? Okay, it's the same process. Take the square root of both sides. We have x plus 2 is equals to positive or negative. The square root of 9 is 3. We subtract 2 from both sides. And so in here, my x is going to be equals to either positive 3 minus 2 or negative 3 minus 2. Negative 3 minus 2. Notice that the minus 2 stays the same. It's just the 3 that is positive or negative. And so the two possible answers for x is 3 minus 2 is 1, and negative 3 minus 2 is negative 5. Again, later on you will learn that it's because my parabola is going to be the x intercepts are going to be at 1 and at negative 5. And it can be like this or like that. Okay? So the answer for this one is 1 or negative 5. Okay, let's see. We have x plus 1 all raised to the second power is equals to 2. Again, the first step is the same. We take the square root of both sides so that we can cancel this square. And so x plus 1 is equals to, as you can see, the 2 is not one of those perfect squares. So we cannot put it as a whole number. So we're just going to leave it as plus minus the square root of 2. Then we cancel minus 1, so that we can cancel this. And so x is equals to, we can never combine a whole number with an irrational number. So we're just going to bring down this negative 1 in here, and then write this whole thing in front of it, plus minus the square root of 2. Once we get to graphing, we're going to have to simplify this as a decimal number, an approximate decimal number, and we're going to be adding and subtracting it from negative 1. But we'll worry once we get there. Okay? So these will be the two answers. This is one path, and this is the other path. Okay, one answer and two answers. Okay. Okay, again, now we have the answer equals to negative 4. You know what that means. When we take the square root of a negative, this cancels. But in here, what happens? what happens with a negative? We always know that we need to put plus or minus. When we have a negative, we put that imaginary number, and the square root of 4 is 2. We subtract 1 from both sides. That cancels. And so x is equals to, we bring down this like that, and then this in front of it. Okay? It's going to be -1 plus or minus 2 imaginary number. So we cannot combine these ones, and the reason is because this has a variable and the negative one doesn't have a variable. So they're not like terms, we cannot combine them. Okay, so that's the lesson for today. You can now enjoy doing 10.7, and I hope this video was helpful.